Okay, quiz 2.1 through 2.3 review. Number 1 asks to find a counterexample for the following conditional. If you live in Springfield, then you live in Illinois. Okay, so two possible counterexamples would be Springfield, Missouri or Springfield, Maryland. What we're looking for a counterexample is a city that is Springfield, but a state that is not Illinois. So a hypothesis that is still true and a conclusion that is false. So any state that has Springfield for a city that is not Illinois would be a correct counterexample. Number 2, find a counterexample to the following faulty definition. A square is a figure with 4 congruent sides. Okay, so a good definition, in order to be a good definition, you have to be able to write the conditional as a biconditional. Okay, unfortunately, the converse of this conditional is false. Okay, the reason being, another figure that has 4 congruent sides is a rhombus. Okay, so you could come up with any other shape that has 4 congruent sides that is not a square, and that would be an acceptable counterexample. Number 3, what is the law of detachment? Looking back in your notes, you can see the law of detachment states, if a conditional is true and its hypothesis is true, then its conclusion has to be true. Number 4 asks, what is the law of syllogism? Syllogism allows you to state a conclusion from 2 true conditional statements when the conclusion of one statement is the hypothesis of the other. Number 5, identify the hypothesis and conclusion of this conditional. Okay, our conditional is if 2 lines are perpendicular, then they intersect to form right angles. And looking back, hypothesis comes after our if, so the hypothesis would be if 2 lines are perpendicular, and our conclusion comes after then, so it would be they intersect at right angles. Number 6, we need to write this statement as a conditional in if-then form. Okay, so we're given a statement, all triangles have 3 sides. Okay, some of the wording may be a little bit different, so as long as it gets this general, it's fine. Okay, so our if-then conditional form would be, if it is a triangle, then it has 3 sides, or if the shape is a triangle, then it has 3 sides. Number 7 is a fill in the blank. Another name for an if-then statement is a conditional. Every conditional has 2 parts. The part following the if is the hypothesis, and the part following then is the conclusion. Number 8, what is the converse of the following conditional? If the point is in the first quadrant, then the coordinates are positive. Okay, the converse of that, which remember converse means to flip the order, would be if the coordinates are positive, then the point is in the first quadrant. Number 9, for the following true conditional statement, write the converse. If the converse is true, combine the statements as a biconditional. So our conditional is if x equals 2, then x squared equals 4. Our converse would be if x squared equals 4, then x equals 2. Now this converse is actually false. A counterexample for this example would be x equals negative 2. Okay, so if we put that x squared equals 4 first, our hypothesis, we could have 2 separate conclusions for that. Number 10, determine whether the conditional and its converse are both true. If both are true, combine them as a biconditional. If either is false, give a counterexample. Okay, if 2 lines are parallel, they do not intersect. That is true. If 2 lines do not intersect, then they are parallel. Okay, this is false because we could have skew lines. Skew lines are not parallel and they do not intersect. Number 11, write the 2 conditional statements that make up the following biconditional. I drink juice if and only if it is breakfast time. Our conditional, we're going to keep the same order using if and then. Okay, it would be if I drink juice, then it is breakfast time. Our converse, flip the order, would be if it is breakfast time, then I drink juice. Okay, again, number 12 is a fill in the blank. When a conditional and its converse are true, you can combine them as a true biconditional. Number 13, what is the converse and the truth value of the converse of the following conditional? If an angle is a right angle, then its measure is 90. Our converse, flip the order. If an angle measures 90, then it is a right angle. This is true. Number 14, we want to write the converse of the conditional statement. Determine the truth value. If the converse is false, provide a counterexample. So our conditional is, if an integer ends with 0, then the integer is divisible by 2. Converse, flip the order. If an integer is divisible by 2, then the integer ends with 0. Okay, this is false. Okay, so think of any integer that is divisible by 2 that does not end with 0. That would be a possible counterexample. The counterexample I came up with would be 4. 4 is divisible by 2 but does not end in a 0. Number 15, rewrite this definition as a biconditional. Points that lie on the same line are collinear. So biconditional, we need to use if and only if. So the way I wrote it was points lie on the same line if and only if they are collinear. Number 16, find a counterexample to show that the following statement is not a good definition. Okay, remember back in the very beginning, a good definition is one that we can write as a biconditional. Okay, so a computer is a machine with a keyboard and a memory. Okay, so if we flipped the order and had something that had a keyboard and a memory, and it was a computer, is there any other machine that has a keyboard and memory? That is not. Okay, the one I came up with was a calculator. So if you can think of something else that is a keyboard and a memory that is not a computer, that would be a good counterexample. Number 17, use the law of detachment to draw a conclusion. If a student is on the basketball team, then that student has passing grades. Teresa is on the basketball team. Okay, so it tells us in the conditional that if any student is on the basketball team, then they have passing grades. It then tells us Teresa's on the basketball team. So our conclusion is that Teresa has passing grades. Number 18, use the law of detachment to draw a conclusion. If you miss the bus, then you will be late for school. You are late for school, so our conclusion is you must have missed the bus. Number 19, use the law of syllogism to draw a conclusion. If a student studies geometry, then the student studies mathematics. If a student studies mathematics, then the student's mind is expanded. Okay, so I underlined the conclusion and hypothesis that were the same. Remember, we're going to combine the two that are not underlined. So our conclusion would be if a student studies geometry, then the student's mind is expanded. And last, number 20, write the converse and the biconditional, if possible, of the following conditional statement. If 3 points are collinear, then they lie on the same line. Our converse, flip the order. If 3 points lie on the same line, then they are collinear. Okay, since our conditional and our converse are both true, we can write a biconditional. Biconditional, switch it back to the original order. So we have 3 points are collinear if and only if they lie on the same line. And that is the end of 2.1 through 2.3 quiz review.